Welcome to The Biologist. Please like, share and subscribe my channel for more biology related videos. Today we are going to talk about radioimmunoassay. What is radioimmunoassay? Radioimmunoassays are used to measure the concentrations of biologically relevant proteins and hormones in body fluids, although many radioimmunoassays have been replaced by enzyme-based immunoassay. So what is an enzyme-based immunoassay? Name one enzyme-based immunoassay. Enzyme-linked immunosorbent assay, which is used to detect dengue. It is mostly found in Africa and Asian regions, in which NS1 antigen is used. Some hormonal measurements are still made using this technology. Okay, history. So what is the history of radioimmunoassay? Before we get to know the working of the radioimmunoassay, we should know the history and how it has been developed and who developed it. It was developed by S.A. Burson and Rosalind Yellow in 1960. They were two endocrinologists, designed a technique to determine the level of insulin/anti-insulin complexes in diabetic patients. Their technique soon proved its value for measuring hormones, serum proteins, drugs and vitamins. Thus, radioimmunoassays made it possible to measure substances that had been undetectable by many quantitative technology. Since the initial description of Yellow's assay, many technical variations have been developed to make the method more rapid and reliable. As generation passed, so it has been seen that radioimmunoassay has been modified so that it becomes more quick and it becomes more reliable, or it becomes more accurate. However, all these variations depend on the availability of radioactively labeled antigen or antibody and a method by which to separate antigen antibody complexes from unbound reagents. Most RIAs, that is radioimmunoassays, used are based on the binding of the antibody or antigen to a solid phase support, such as PVC wells of a microtiter plate. The radioactive label that most commonly used is I-125, which binds to the exposed tyrosine residue on the protein. So what is the most used radioactive label? It is I-125, and where it binds? It binds to the tyrosine residue on the protein. Tyrosine is an amino acid which binds where the radioactive label binds. So what is the method of the radioimmunoassay? So we get to know about the what is radioimmunoassay. We get to know about the history of the radioimmunoassay. Now we get to know about the method of the radioimmunoassay. The labeled antigen is mixed with antibody at a concentration that saturates the antigen binding site of antibody. Then test sample of unlabeled antigen of unknown concentration are added in progressively large amounts. The antibody does not distinguish labeled from unlabeled antigen. So the two kinds of antigen compete for available binding site on the antibody. As the concentration of the unlabeled antigen increases, more labeled antigen will be displaced from the binding site. So what happens? As the concentration of the unlabeled, which are not radioactively labeled antigen, increases, more labeled antigen will be displaced from the binding sites. The decrease in the amount of the radio-labeled antigen bound to specific antibody in the presence of the test sample is measured in order to determine the amount of antigen present in the test sample. The antigen is generally labeled with gamma emitting isotopes such as iodine 125, which we learned before that it is the most commonly found radioactive label, right? And where it binds to the tyrosine residue on the proteins, but the beta emitting isotope such as tritium can also be used. The radio-labeled antigen is part of the assay mixture. The test sample may be complex mixture such as serum or other body fluids that contain unlabeled antigen. The procedure requires small amount of sample and can be conducted in small 96 well microtiter plates. Hence, the procedure is suitable to determine the concentration of the particular antigen in large number of samples. Example: A microtiter radioimmunoassay can be used to screen for the presence of the hepatitis B virus to determine the amount of labeled antigen bound the antigen antibody complex is precipitate to separate it from free antigen, and the radioactivity in the precipitate is measured. A standard curve can be generated using unlabeled antigen samples of known concentration in place of the test sample, and from this plot the amount of antigen in the text mixture may be precisely determined, right? So here we can understand the procedure more broadly. There are radioactive antigen. First antibody, add unlabeled antigen which are not radioactively labeled, right? Then it is displaced by radioactive antigen, precipitate by antigen antibody complex with anti-immunoglobulin, which is the second antibody. Radioactivity of the supernatant free antigen, which we can see here, the red and the blue, which are surrounded by the antigens are the blue, and the red are the antigens, and the labeled and the unlabeled antigens. Radioactivity of precipitate bound antigen, and then the second antibody comes. Thank you. Please like, share and subscribe my channel for more biology related videos. Thank you.